The universe has a way of teasing us, whispering secrets that feel just out of reach, like a shadow moving in the corner of your eye. Imagine for a moment a world exactly like ours, same size, same orbit, same sun, yet perfectly hidden, always on the opposite side of that blazing star. A twin Earth, a mirror of everything we know, tucked away in the cosmic blind spot. The ancient Greeks, those starry-eyed Pythagoreans, believed in this idea of a counter-Earth, convinced the cosmos demanded symmetry, a balance so perfect it required a secret world to complete the equation. Picture it, a planet teeming with life, perhaps a civilization staring back at us, unaware, their cities glowing under alien skies. It's the kind of thought that sends shivers down your spine, the kind of mystery that makes you gaze up at the night sky and wonder what else we're missing. But then, reality crashes in. We've sent probes looping around the sun, NASA's stereo mission peering into every corner of our orbit, and found nothing. No hidden twin, no mirror Earth. The math, it turns out, doesn't lie, but it doesn't always play fair either. The delicate balance of a counter-Earth would unravel in the chaotic tug of other planets, their gravity nudging it out of hiding over millions of years. Yet even in its absence, this idea, this dream of a secret world, pushed us to explore, to question, to map the solar system with a precision the ancients could only imagine. It's a story that repeats itself across the centuries. A wild, beautiful theory born from our longing to understand the cosmos, only to dissolve under scrutiny, leaving behind a trail of discoveries we never expected. 200 years ago, the night sky was a canvas of 7 known planets, each a familiar point of light in a universe that felt just small enough to grasp. But there was a problem, a tiny glitch in the clockwork of the heavens. Mercury, the sun's closest companion, was misbehaving. Its orbit wobbled, precessing in a way that Newton's laws couldn't explain. The point where it grazed the sun shifted ever so slightly, defying the tidy equations of gravity that had governed the cosmos for centuries. Astronomers scratched their heads, searching for an answer, and turned to Urbain Le Verrier, a man who'd already proven he could conjure planets from numbers alone. Le Verrier had predicted Neptune's existence with nothing but a pen and paper, so when Mercury started acting up, he was the cosmic detective everyone trusted. He dove into the math, his mind a whirlwind of calculations, and emerged with a bold claim. There must be another planet, closer to the sun than Mercury, its gravity tugging just enough to explain the wobble. He named it Vulcan, a fiery world born in the crucible of the sun's glare. Astronomers hunted for it, squinting through telescopes during solar eclipses, chasing fleeting shadows across the sun's disk. Some swore they saw it, a flicker, a speck, but the sightings never held up. The total eclipse of 1878 was the final blow. Astronomers scoured the sky, and Vulcan was nowhere to be found. Then, in 1915, Einstein stepped in, not with a telescope, but with a radical new vision of the universe. His general relativity didn't need a ghost planet. Gravity, he said, wasn't just a force. It was the bending of space-time itself, a cosmic fabric warped by mass. Plug Mercury's orbit into his equations, and the wobble made perfect sense, down to the last decimal. Vulcan vanished, a phantom born of incomplete physics, but its death gave us something far greater. A theory that unlocked black holes, gravitational waves, and the bending of time itself. The search for a planet that never was rewrote our understanding of reality. But the cosmos wasn't done teasing us. Beyond Mercury, between the orbits of Mars and Jupiter, another mystery beckoned. In the early 1800s, astronomers were obsessed with a mathematical pattern called the Titius-Bode law, a formula that predicted the distances of planets from the sun with eerie precision. It suggested a planet should exist where none had been seen, right in the gap between Mars and Jupiter. A group of scientists, calling themselves the Celestial Police, banded together to hunt for this missing world. In 1701, they found something. Ceres, a tiny rocky body, not quite a planet, but undeniably there. Then came another, and another, until the sky revealed not a single world, but a swarm of fragments, the asteroid belt. The celestial police didn't find a planet, they found a graveyard. They imagined a lost world, Phaeton, shattered by some cataclysmic disaster, its pieces scattered across the heavens. It was a story ripe for science fiction, a cosmic murder mystery. But as telescopes grew sharper and we weighed the asteroid belt, the truth emerged. All those fragments together barely amounted to a fraction of the moon's mass, nowhere near enough to form a planet. Jupiter's immense gravity, it seemed, had churned the region into chaos, preventing a planet from ever forming. Phaeton wasn't destroyed, it was never born. Yet in that chaotic belt, we found a clue. Psyche, a strange metallic asteroid, reflecting radar like a chunk of raw iron. Scientists now believe it might be the exposed core of a protoplanet, a world that started to form before collisions or gravity stripped it bare. The idea of Phaeton, though wrong, led us to a relic of creation itself, a glimpse into the violent birth of worlds. The outer reaches of our solar system are a realm of shadows, where the sun's light barely touches, and mysteries grow like frost in the dark. Beyond Neptune, past Pluto's lonely orbit, the Kuiper Belt stretches, a vast ring of icy debris, remnants of a solar system that never quite finished forming. For years, astronomers noticed something strange out there. A handful of distant objects, scattered like cosmic breadcrumbs, seemed to align in ways they shouldn't. Their orbits weren't random, they clustered, as if nudged by an unseen hand. The idea of Planet 9 was born, a massive hidden world, perhaps 10 times Earth's mass, lurking so far out it takes thousands of years to circle the sun. It was a thrilling thought, a frozen giant, invisible to our telescopes, shaping the paths of these distant wanderers with its gravitational pull. The hunt was on, with astronomers scouring the sky, chasing a ghost that promised to rewrite our cosmic map. But then, in 2025, a new discovery threw everything into question. A dwarf planet dubbed 2017 BP emerged from the darkness, its orbit defying the neat pattern Planet 9 was supposed to enforce. Run the simulations, and this tiny world should have been flung out of the solar system long ago if a massive planet was out there. The math didn't lie. Planet 9's case began to crack. Scientists now suspect the clustered orbits were a trick of our own eyes, a bias in how we observe the sky, like seeing faces in clouds. But the story doesn't end there. Instead of one giant planet, researchers propose there could be hundreds of smaller worlds. Dwarf planets like Pluto, Sedna, and this new arrival, hiding in the Kuiper Belt's shadows. Picture it, up to 200 frozen worlds, each a potential treasure chest of secrets. When we sent New Horizons to Pluto, we found glaciers, hazy skies, maybe even a hidden ocean beneath its icy crust. Now imagine 200 Plutos, each with its own story, some perhaps cradling the faint chemistry of life in their frozen depths. Planet 9 may be fading, but the idea of it pushed us to look deeper, to dream bigger. And what we're finding is a cosmic frontier wilder than we ever imagined. The search for hidden worlds doesn't stop at our solar system's edge. It stretches into the void beyond, where the stakes feel even higher. Back in the 1980s, a chilling pattern in Earth's fossil record caught the eye of physicists Daniel Whitmire and Albert Jackson. Mass extinctions, those cataclysmic resets that wiped out dinosaurs and countless other species, seemed to strike every 26 million years, like a cosmic clock ticking down to doom. What could cause such a rhythm? They proposed a haunting answer. Nemesis, a faint red or brown dwarf star, the sun's dark twin, orbiting far beyond Pluto. Every 26 million years it would swing close, stirring the Oort cloud, a vast icy shell encircling our solar system, and send a barrage of comets hurtling toward Earth. A cosmic villain, elegant and terrifying, Nemesis captured imaginations. Telescopes turned to the sky, hunting for a dim glow that could betray its presence. The Wide-Field Infrared Survey Explorer, built to spot faint, cold objects, scoured the heavens. Nothing. No star, no signal. The extinction cycle itself began to look less certain, the pattern more coincidence than clockwork. Nemesis faded, another ghost laid to rest. But the search wasn't wasted. Mapping the outer solar system in unprecedented detail, we learned to track long-period comets, those rare visitors that could one day pose a real threat. Nemesis, though it never existed, sharpened our gaze, teaching us to watch the skies not just for danger, but for the unexpected. Rogue planets, interstellar visitors, or phenomena we haven't yet dreamed of. Each failed theory, from counter-Earth to Nemesis, is a spark that lights a new path, a reminder that the universe rewards the curious, even when it keeps its secrets just out of reach. The universe is a master storyteller, always holding back just enough to keep us hooked, dangling clues that spark our wildest dreams. Beyond our solar system, the search for other worlds, planets that might mirror Earth's promise, has consumed us for decades. In 2016, the discovery of TRAPPIST-1, a dim red dwarf star just 40 light-years away, felt like a cosmic jackpot. 7 Earth-sized planets, 3 nestled in the so-called habitable zone, where liquid water could exist, orbited this tiny star. The headlines roared with hope, a compact solar system, a sci-fi dream where rocky worlds might harbor oceans, clouds, maybe even life. We imagined stepping onto these planets, new homes for humanity, or finding alien ecosystems thriving in their alien glow. But dreams, as always, collide with the universe's hard truths. The James Webb Space Telescope turned its golden eye on TRAPPIST-1, and the vision crumbled. The planets closest to the star weren't lush or welcoming. They were scorched, bare rock, stripped of atmospheres by the red dwarf's relentless flares. These stars, small as they are volatile, bombarding their planets with radiation far fiercer than our sun's worst tantrums. To stay warm enough for water, a planet must hug a red dwarf so closely it risks being tidally locked. One side eternally roasted, the other frozen in perpetual night. No atmosphere could withstand that assault for long. Stellar winds peel it away like ash in a storm. TRAPPIST-1, once our best hope, became a cautionary tale. Red dwarfs, making up 3/4 of the galaxy's stars, were thought to be cradles for life. Now they look more like cosmic furnaces, hostile to the delicate balance life demands. Yet even in disappointment, there's wonder. The search for these worlds taught us how to read distant atmospheres, how to parse starlight for whispers of water or oxygen. Each barren planet is a lesson, sharpening our tools for the day we find one that isn't. Then there was K218b, a planet that briefly stole our breath. Orbiting a red dwarf 120 light-years away, it seemed to defy the odds. Early data from the James Webb Space Telescope hinted at water vapor, carbon-based molecules, and, most tantalizingly, dimethyl sulfide, a chemical tied to life on Earth, produced by bacteria in our oceans. For a moment, it felt like we'd caught a glimpse of something alive, a super-Earth with oceans under a hydrogen-rich sky. Scientists like Niku Madhusudan dared to dream, calling it the strongest sign of extraterrestrial life yet. But the universe loves to play tricks. Closer scrutiny revealed K218b wasn't a rocky world like ours, but likely a mini-Neptune, its oceans buried under a crushing atmosphere, sunlight a distant memory. The dimethyl sulfide signal? It faltered under new models, possibly a mirage born of exotic chemistry or the star's own flares warping the data. Sarah Seeger, a titan in astrobiology, warned that the telescope's view through a star's light can distort reality, conjuring false biosignatures like a cosmic illusionist. K2-18b isn't a dead end. It may still hold strange, alien chemistry, but it's taught us caution, urging us to temper hope with rigor. The universe doesn't hand out answers easily. It demands we learn its language first. And then there's the wow signal, the one that still haunts us. In the summer of 1977, a radio telescope in Ohio, part of the SETI project, caught something extraordinary. A 72-second burst of narrowband radio waves at 1420 megahertz, the frequency of neutral hydrogen, a cosmic dial tone any advanced civilization might use to say hello. Astronomer Jerry Amon circled the printout, scrawling "wow" in red ink, and a legend was born. It was clean, focused, not a drifting satellite or local noise, appearing in one scan but not the next, as if it came from deep space and vanished. Theories exploded. A beacon from a distant star, a probe's fleeting ping, a message from a civilization we'll never meet. For decades, it stood as the best candidate for alien contact, but the signal never repeated, leaving us grasping at shadows. In 2022, some pointed to a comet, suggesting its hydrogen emissions reflected an Earth signal. Yet tests on other comets found no match. Then in 2024, a new idea emerged from Arecibo's final data. Astronomer Abel Mendez proposed a magnetar, a neutron star with a monstrous magnetic field, flaring through a hydrogen cloud, triggering a natural masser, a laser-like radio burst at exactly 1420 megahertz. A 1 in a billion cosmic alignment, gone in an instant. Not aliens, but a message from the cosmos itself, a reminder of its vast, untamed strangeness. They wow. Signal wasn't a false alarm, but it wasn't what we hoped either. It was a fleeting glimpse of the universe's deeper mysteries, urging us to keep listening, to keep searching, because the next signal might be the one that changes everything. Even our own moon, so close we can see its scars, once fueled wild dreams. In the early 1800s, astronomer Franz von Paula Gruithuisen claimed he saw colorful bands and circular structures on its surface. Proof, he thought, of lunar jungles and alien cities. Newspapers spun the tale into a frenzy, imagining a living moon. Better telescopes revealed the truth. Craters, not cities. Barren rock, not greenery. Yet that fleeting vision of a vibrant moon drove us to map its surface with care, to learn its lifeless story. Every cosmic myth, Counter-Earth, Vulcan, Phaeton, Nemesis, TRAPPIST-1, K2-18b, the WOW signal, has led us astray, only to reveal something greater. The universe doesn't owe us answers, but it rewards our curiosity with questions that reshape our reality. Planet 9 may be gone, replaced by a swarm of dwarf planets, each a frozen enigma. We're still out here, eyes on the sky, chasing the next impossible dream, knowing that even if it fades, it'll light the way to something we never saw coming.